Welcome back to 121st episodes of this channel. So we now come to 121 videos in this channel for mathematics. So I hope everyone enjoyed the video so far, but some of you only watch one video or two videos. But if you watch the whole lot to get a most benefit out of the channel, so you might consider to subscribe this channel, so you don't have to search every time to find that channel name. So you can get the playlist in one occasion, so you can access more than 100 videos for your mathematics learning. So if you haven't subscribed channel, you can just click on the bell, and doesn't cost you anything. Just simply do that. Thank you. All right, today we're going to do vector calculus question. So we got question 8 of 2022 VCE Specialist Math Exam 1. So this we call calculus, vectors calculus. So we know vectors calculus involved with velocity and acceleration and displacement. So excuse me. Okay, so we need to first, we got the question written as a body moves straight line so that its displacement. So sometimes displacement we use xt. We know is a dv dt. So relationship between the velocity and displacement using different derivative. So we also know the vt is derivative of at, and we know at is derivative of vt. All right, so that's all the relationship we use. So now obviously it's a double derivative x displacement with respect to time. So we given the acceleration, so this question is given the at, so in relation to displacement is given 4xt. Then we also got velocity. So the a0 is 0, velocity at the rest is also -2 millimeter per second. And now obviously at the rest, so the velocity displacement also 0, we've given those conditions. So we need to determine what is the velocity in function in terms of x. So we need to find out that. So let's do that. So first, let's solve this question. I'm going to start with at using the dv dt. So I'm going to also use dv dx times by dx dt. So you can see I'm going to multiply, so divided by dx, then so I got separated two steps of differentiation. All right, now dv dx we equal v, then dx dt is v, and then times by dv dx, because we need to find the velocity with respect to x. So we needed that function. So then we're going to move, because you got v outside, what I'll do is move d to the inside of differentiation. So we put d with respect to x in the bracket will be half of the v squared. So that's formula we're going to use. So now, because of AT is given is negative 4xt, so I'm going to substitute into the function. So it'll be negative 4x equal to differentiation of with respect, so it'll be half v squared. So that's how we got that formula first. So now we're going to undo that difference. So we both ends to integrate it. So the right-hand side has become half of v squared. This side is become negative 4x squared dx. So we're both sides using dx to integrate it, plus e, obviously. Then we further going to be half of v squared is equal to, now integrate for that. Sorry, my apology, it doesn't have a square there. So there'll be negative 2x squared plus c. So I'm going to take away t, so we put a c1. So it'll be negative 4x squared plus c. So that's my initial function, but we have to decide v in relation to x. So we need to decide what the c is. So let's using the condition we are given. So we know when the velocity equal to 0 at a t times 0 is negative 2, and x is also 0. So we substitute into the function, so we know how to find a c. So we negative 2 squared minus 0 plus c, so therefore c is 4. So therefore we will get v squared equal to negative 4x squared plus 4. So now we're going to undo the v squared, become positive and negative square root of, I'm going to put a 4 minus 4x squared. So I'm going to simplify to 4, take it out, become 2, 1 minus x squared. Now, the problem is this is not a function because we got two results. One is a positive, one negative. So we need to change to function because the functions only have a one fx. So which one we choose? Now, because we know when the velocity given the condition at 0 was a negative value, so therefore I'm going to choose the negative. Otherwise, you wouldn't get a positive or negative 2. So if you said substitute into that, so the v should be negative 2. So therefore, we choose a negative 2 0 square, which is negative 2. So therefore, we confirm the v should be chosen negative 2, not positive. Otherwise, it will be contradict to our given condition. So the final answer is the velocity in relation to x is given by this particular function. So that's it. We solved that question. Hopefully you enjoy the solution. So if you do, please give us the thumbs up and we'll see you next time. Bye.